This is a 7-1 to 7-5 practice assessment. In problem number 1, it says if the tangent of theta is negative 2/3 and theta is between 90 and 180 degrees, find the secant of theta. Well, in order to do that, we're going to have to first start with this information and draw a right triangle on the coordinate plane in the correct quadrant. Well, 90 to 180 is quadrant 2. So I'm going to draw me a coordinate plane, and we're going to draw our triangle here in quadrant 2. Remember, theta is always going to be the angle closest to the origin. One side of the triangle is on the x-axis, and the third side is parallel to the y-axis, but it's never on the y-axis. So if the tangent is negative 2/3, that must mean that I know the side opposite and the side adjacent. So this is opposite and adjacent. But if it's negative, one of those two has to be negative, and it's this one, because quadrant 2 is where x is negative. So now we need to find the hypotenuse, and instead of using a squared plus b squared equals c squared, we're going to use x squared plus y squared equals r squared. So x squared plus y squared is equal to r squared. So I get 4 plus 9 is r squared. 4 plus 9 is 13, so r is the square root of 13. Well, now that I know the third side, now I can find the secant. Remember, secant is the reciprocal of cosine. So if I find out what the cosine is, which is adjacent over hypotenuse, then the secant must be its reciprocal, which is hypotenuse over adjacent. In problem number 2, if the secant of theta is 5/3 and theta is between 3 pi over 2 and 2 pi, find the cosine of theta. Well, first of all, that's quadrant 4. However, we really don't even need to know that, because if you remember that secant and cosine are reciprocals, then the cosine just must be 3/5. If you go and draw your triangle, like we did in problem 1, and you find the missing side, you end up with this same answer in the end. Number 3, simplify tangent theta over sine theta. When we simplify trig expressions, one of the tricks is to convert everything to be in terms of sine and cosine. Tangent is the same as sine over cosine. Anytime you have a fraction within a fraction, the next step would be to take the numerator and divide it by the reciprocal of the denominator. Notice that those signs cancel and you're left with 1 over cosine. And 1 over cosine is the same as secant. In problem 4, if I do the same thing that I did in problem 3, where I go to simplify this trig expression by switching everything to be in terms of sine and cosine, the only thing that I can switch is cotangent. So I get cosine times, cotangent is cosine over sine, plus sine. The next step would be to multiply these fractions. When you multiply fractions, you multiply straight across, so it's cosine squared over sine plus sine. Now I need to add these fractions, and I have that little process I gave you for adding them when they don't have a common denominator. So you're going to first multiply up this way, so you get cosine squared plus sine squared all over sine. But sine squared plus cosine squared, we know according to our identities, is 1. And 1 over sine simplifies to cosecant. In problem number 5, if cotangent times secant is equal to 3, find sine x. We're going to do a similar process because we're going to simplify the left-hand side into a single trig function and see if that doesn't simplify into sine. So cotangent was cosine over sine, and secant is 1 over cosine. So what ends up happening is these cancel, and you're left with 1 over sine is equal to 3. Well, then if I flip this side, then I also have to flip this side. And we find out that the sine of x is equal to 1/3. Problem number 6 wants us to use the double angle identities to find sine 2 theta, cosine 2 theta, and tangent 2 theta if the cosine of theta is 3/8 and the angle's between 270 and 360. So the first thing we're going to have to do is draw a triangle and then find the missing side of the triangle because we're going to need that information to find the double angles. Our triangle is going to be in quadrant 4. So here's my triangle in quadrant 4. Cosine is adjacent over hypotenuse. And we're going to go find the opposite side. Now remember, we're in quadrant 4. And in quadrant 4, y is going to be negative. So x squared plus y squared is equal to r squared. 9 plus y squared is 64, so y squared is 55, so y is the square root of 55. But we're going to make that negative square root of 55. Now I'm ready to go use the double angle identities. The double angle identity for sine was 2 times the sine of theta times the cosine of theta. So 2 times the sine of theta is going to be negative square root of 55 over 8 because it's opposite over hypotenuse. And we already know cosine is 3 over 8. So when I multiply those together, I multiply all the numerators. I get negative 6 square root of 55. And then I multiply the denominators, and I get 64. However, if you can reduce this, you need to. And it reduces to negative 3 over 32. So it's going to be negative 3 square root of 55 over 32. For cosine 2 theta, you have a couple of formulas to choose from. The one that I'm going to choose is this one. The reason I chose this one is because I already know the cosine of theta, and it doesn't have a radical in it. And so if I can pick one without a radical, I try to. It's not always possible, but if you can. So 2 times the cosine was 3/8 squared minus 1. First you have to square 3/8, and then you have to multiply by 2. And then you have to subtract 1. And then if you can reduce it, you should. It's going to be negative 23 over 32. Then for the last one, tangent 2 theta. Because tangent is sine over cosine, tangent 2 theta must be sine 2 theta over cosine 2 theta. So it's going to be negative 3 square root of 55 over 32 divided by negative 23 over 32. Remember, with fractions, you take the fraction in the numerator and multiply it by the reciprocal of the one in the denominator. These end up going away, as do the negatives, and you're left with 3 the square root of 55 over, that doesn't look good, 23. Last one, number 7. We want to solve this trig equation, and anytime you have an equation, first of all, it helps if we either have one trig function or if there's something we can take a greatest common factor out of. I want you to notice it's a quadratic, but since it's not a trinomial, we don't have to factor it or use our calculator. We're going to factor out the greatest common factor, which is cosine. Remember, factor means divide. So if you divide these both by cosine, you're left with 2 cosine theta minus square root of 2. And then we're going to do the zero product property. The zero product property says set each of the factors equal to 0. So I'm going to set cosine theta equal to 0. I'm going to set 2 cosine theta minus square root of 2 equal to 0. So when you solve this in your calculator, make sure you're in degree mode. And then this one wants the answers in radians, so we'll just convert it back to radians when we're done. So the inverse cosine of 0 is 0, or it's not, it's 90. And 90 degrees is pi over 2. Is there another place, though, where the cosine is going to be 0? Well, Remember I said on the unit circle, we know these ordered pairs. 1, 0, 0, 1, negative 1, 0, 0, negative 1. All the ordered pairs where the terminal rays hit the unit circle are always the ordered pair cosine, comma, sine. So I know that at 90 degrees the cosine is 0. Well, there's another place where the cosine is 0, and it's down here. And that angle is 270, which is 3 pi over 2. Now let's go solve the second equation. First I'm going to add square root of 2, and then I'm going to divide by 2. And then I'm going to inverse cosine square root of 2 over 2. And the calculator spits out 45 degrees, which is pi over 4. But the question is there another quadrant where I'm going to get this answer? Well, you have to ask yourself, where is cosine positive? Well, cosine is positive in quadrant 1 and 4. So the angle in quadrant 4, whose reference angle is pi over 4, is 7 pi over 4. So this problem resulted in 4 answers. Sometimes it results in 3, sometimes it results in 2. The ones we give you shouldn't result in any more than 4 answers. And that's the practice assessment for 7.1 to 7.5.